Hello everyone. I am sorry that I'm going to be out of school again because of this jury service on Wednesday. Good news is this should be the last day that I need to be there. So I'll be back with you from Thursday. I'm going to make a couple of videos in the next two bits of the decision chapter that we're looking at. So I'll talk through the notes on early and late event times in this one. And then in the next one, we'll cover critical activities, possibly also floats as well. And just see how far you get through it. Of course, the more you can get through, the better, so that we can hit the ground running from Thursday onwards. So without further ado, let's look at early and late event times. So we've looked so far at our precedence tables, and we've looked at how to draw activity networks from the precedence tables. And in the last section, we looked at dummy activities, so how to draw these on when they arise. Early and late event times are really the soonest and the latest that we could complete each event in the diagram according to the times. Now, in the previous video when we saw the little times in the brackets, I said we're going to talk about these later. So these numbers represent the time to complete the activity. So because of the various interdependencies and the different ways we could do things, we could complete these activities at different times. And the early event time is the earliest time of arrival at the event, so the earliest time it can start. And the late event time is the latest time you can leave, so the latest time it must finish by without delaying the overall project. So this is going to be really useful for project management. So in order to get the early event times, we're going to do what we call a forward pass. So starting from the source and finishing at the sink. And then to find the late event times, we're going to go backwards from the sink and end up at the source to find those. That's going to make sense when I show you how we're going to do it. Okay, I'm going to do the early times in green, and the red times will be the late event time. So early event time in green, and I'll do the late event time in red when I come to that. Okay, let's have a look at this activity network. And now you'll notice that we've got our boxes drawn in for the early and late event times. The source node always has 0 for its early and late times. So we're just going to start with 0 for the early event time. Okay, let's see where we can go with this. So let's start with the ones where there's only sort of one path to get to them. So do you notice there's only one way to get to B on this diagram? There's no other way to get to B. A, for example, I could go up to B and I can go down the dummy activity to get to A. So there's actually two ways. To get to B, there's only one way. So the earliest I can get there is going to be 5, a time of 5, because this activity takes 5 to complete. Equally for C, there's no other way I can get to C. The earliest time I can get there is going to be 3, because C takes 3. Now, for A, I could either complete within 4, if I go this way, or I could go up, complete B, and come down to complete in 5. Now, we always pick the largest early time, or the latest early time, in this case 5, because what we're saying is by the time we move off from this event over here, we need to have completed B and we need to have completed A. And we can't, if we've put a time of 4, there's no way we could complete B as well as A within a time of 4. We need to complete B as well in order to move on to activity F. So that's why we pick the largest time in effect. Okay, let's keep going. So let's go for D. So there's only one way to get to the next box. So that's going to be 9. So I'm going to add 6. So the earliest I can get there is 9, because I'm at a time of 3 over here. I need to add 6 to that. For E, to get to this box, there's actually 2 different routes I could take. So I could go from 5 from this box over here, and it would take a time of 7, so it could take me 12 if I go that way. If I go via A, well, A is gonna, well, this event, sorry, is gonna have an early time of 5. If I add 5 to that, it's gonna give me 10. So remember, I always pick the biggest time because I need E and F to be completed by the time I get to this event. So the early time is going to be 12. Now there was one other option as well, actually, that I missed off. If I'd gone from this event over here up G, it would have taken me, it would have given me a time of 9 plus 4, which is going to be 13. So actually, my bad, it's going to be 13, actually, because we also need G to be complete by the time we get here as well. So the quickest way we can achieve that is in a time of 13 from the start time. Okay, so completing I then, there's only one way to get to this event over here. So 13 plus 5 is going to give me 18. This event over here, I could get there in 9 plus 2, so in 11. Or I could also get there from coming from this event over here at 13 down the dummy activity, which is a time of 13. So dummy activities don't have any weight to them. We just take the early time from the previous event. And we're looking for the largest, so 13. And that's because by the time we get to this event, we need to have completed H and we need to have completed all of these ones, so E, F, A, B, etc. Okay, so this box over here, we can get there in 18, coming down from the event at the top, or in 13, coming from the event at the bottom. So it's going to be 18. Going to this event over here, there's only one way I can get there, 13 plus 4. So in 17, I can get there. Okay, and there's a few different options for the last one. So I could do it in 17 plus 5, which is 22. I could do it in 13 plus 6, which is in 19. I could do it in 18 plus 2, which is 20. Or I could do it in 18 plus 6, which is 24. And I'm going to pick the largest number as before, because I need all of those activities to be complete, and the earliest time I can complete everything is going to be the biggest number, which is 24. Okay, so that is the early event times done. If we read the box over here, it says the sync node always has the same early and late times. So we always take the same time. And now we're going to work backwards along the branches in a similar process. This time though, we're going to take the smallest late time for the backward pass. So where we put the largest time going forwards, and that gave us the soonest that we could complete everything for that event, we're going to go backwards for the late times and take the smallest late time, where there's more than one option, of course. So if I start off with 24, I'm now going to subtract. So I'm going to go backwards along the activities and subtract the times and work backwards like this and pick the smallest one to put in the box. So for this first event with a 17 in it, I'm going to write 24 minus 5, so 19. And there's no other way I can get to that one. So it's just going to be 19. Okay, but this one over here, right next to it, I could get there by going backwards down N and then M. So that would give me a 19 minus 4, which is going to be 15. Or I could go from 24, I could subtract 6 from that. So I could do it potentially in 18. And I'm going to pick the smallest. So it's going to be 15. Going backwards along this branch, I'm going to take 24 minus 2, which is going to give me 22. But I could also go backwards to this event over here, which I said had a late time of 15. So that is also a contender. And let's look at this event over here at the top. 24 minus 6 is just 18, so this late time is just going to be 18. So I could also do it in 18 as well if I went down this dummy activity. So I'm going to pick the smallest. It's going to be 15. Okay, actually I have to apologise because I've done something wrong. I did something a bit silly. When I was looking at this 15 and 18 over here, I was going back along an activity, but then I was going forwards along a dummy. That's not what we're doing. We're meant to be going backwards, so I shouldn't have been doing that. Actually, this one's fairly straightforward because there's only one activity going back into this event. So it just has to be 22. Has to be 22. And equally, if I were trying to get to this event with the 13:15 in it, going back through that event, I'd get to 22. I'd go back along the dummy. It would give me a time of 22, so it wouldn't change what I write in the box. And equally going upwards, I'd have another option for this event potentially, but yeah, it wouldn't count. Okay, let's continue then. So let's go from this event 13:15 then, let's go back along H. So we could get to this one in 15 minus 2, so in 13, but actually need to fill in this event first, so because there's another path going up the dummy and down G as well. So let's fill in this box. 18 minus 5 is going to be 13. And let me just check. So I could also do it in 15 if I go backwards along the dummy, but it's going to be the smallest late time. So 13 is going to be my smallest late time. Okay, 13 minus 4 is going to be my other late time that I could get to this box over here. So 13 minus 4 is 9. So 9 is going to be my smallest late time. Okay, going back along D, I can see that my late time for this event down here after activity C is going to be 9 minus 6, which is going to be 3. This one over here, so the event preceding F, is going to be 13 minus 5. That's going to be 8. And I don't think there's another way we can get there. By going backwards, we'd have to go forwards along the dummy. So I think that one's just 8, fairly straightforward. For the penultimate event then, we could have 13 minus 7, which would give us 6. Or I could have this event over here, so 8 going backwards along the dummy. Well, it's going to be 6, the smallest number. And finally, my source always has 0 as the early and late time. So let's just check that makes sense. Yeah, so if I go, this one's going to give me 0. So if I have a late time of 3 and I go back activity C, I'll get to 0. So that's going to be the lowest number, the lowest number. Now these late times, these relate to the latest time at which I can leave this activity and move on to the next activity. So leave this event, sorry, and move on to the next activity. So it means that, say it's 22 over here, at time 22, I need to, at the latest, leave this event and complete activity K. So it's just going to help us figure out timelines later of these various events. Okay, I've done quite a lot of talking, so if you want to pause the video here and have a go at this next diagram of filling this in with the early and late times, that would be a good idea. I'm going to talk it through just in case you want to see another example being talked through. It can be a little bit confusing at first, but if you're having a go, just pause the videos and then skip to the end and check the answer ties up to your own. Okay, so I'm going to start with the early time on the source of 0. Flowing up to A, I can go here 2 ways. Either direct to A, which would take 4, or via B. So going down to B, there's only one way I can get there. It's going to be in 7. So I'm going to have an early time of 7 for that one. So it's going to be 4 or 7. And if you remember with the early times, I select the largest early time because in order to move on from this event over here, I need both A and B to be completed. So the earliest that can happen is after a time of 7. Okay, flowing on to the next event then. There's 2 ways I can get here. So I'm going to fill in this middle one first. So 7 plus 4 is going to be 11. And that's the only way I can get there, isn't it? Or I could go via this event over here, and that would be actually in 12. So there's 2 ways I could get there. So it's going to have an early time of 12. Then going back up to this event over here, I could get there in 7 plus 2, which is in 9, or in 12, which comes from the box below, which is flowing into it via dummy activity, which signifies dependence. So it's going to be an early time of 12. Okay, looking at activity J, I can see that's going to give me an early time for the last event of 22. But let's now go down this one. So 12 plus 3, if I go along activity I, is going to give me a time of 15. Or if I go from this event here, which I have an early time of as 12, if I add 4, that's 16. And I also could do it in 7 plus 5. So that's in 12. But of course I picked the largest, so it's going to be 16. 7 plus 4 is 11. So this event over here must have an early time of 11. Oh no, it mustn't. So it could be an 11, but I could also get there from this event over here flowing down the dummy line. So that would be in 16. So this is actually 16 for the early time, this one. And finally, 16 plus 5 is a possible early time. So that's 21. And another possible early time is 16 plus 6, which is 22. So I can see that the early time here is going to be 22. So the late time must also be 22. And now we can start to work backwards through the diagram. So 22 minus 6, which is the only way I can get to this one. It's only one activity flowing backwards into it, is 22 minus 6. I don't obviously know how to do that. I'm just having a bit of a brain event. So it's 16. Actually, it's the same. It's the same. 22 minus 5 is also the only way I can get to this one as well, I believe. So 22 minus 5 is going to be 17 then. And 22 minus 10 isn't the only way actually I can get to this top one. So I could do 22 minus 10, which would give me 12. Or I could go backwards along K to 17, and then I could go back along I as well. So that would give me a time of 14. But remember, for the late times, I picked the smallest, because that signifies the latest I can leave that event and move on to the next activity to get everything completed within the time of 22, which is what I'm aiming for. Okay, let's look at this one next in the bottom left corner. So I could go from this event of 16 minus 4 to do a late time of 12. I could go from 17 minus 5, which would also give me a late time of 12. Or I could go from this event over here and go backwards, but I need to work out the late time for this event then. There's 2 possible ways I could get there. I could go from this event up here down the dummy, which would be in a time of 12, or I could go from 17 and subtract 4 from that, so 13, and I'm going to pick the largest, so it's going to be 13, and 13 minus 5 is 8. So I believe this time must be 8 then. Okay, and apologies again because I just noticed something. I don't know if you noticed it too. If you were, well done for being awake. But this one over here is wrong. Can you see why? It's wrong because there's 2 ways I could get there. So I could get there by going back from 22 minus 5 to give 17. But I missed that there was actually another way. I thought there was only one way to get there. I wasn't looking very closely. I could go back from 22 to 16, and then I could go along the dummy, backwards along the dummy activity for a time of 16. So this would give me a late time of 16, and this would knock on and give me the late time of 12 over here. So I'd have two late times that were the same of 12. So 12 is going to go in the box. And equally, going down this branch over here, now that it's 12, 12 minus 5 actually gives me 7 and not 8. So 7 is going to be the smallest over there. Okay, let's finish it then. So looking at this event 12, if I subtract 4 from 12, I'm going to get 8. So that's one way of getting there. Or I could go from the time of 12 over here back to give me 10. And I think that's the only way, 2 ways I can get there. So of course it's going to be the 8. And then finally, early and late times for the source are always both 0. So there you have it, early and late times. Make sure you have a good practice of these from exercise 8C. They are a little bit confusing, and it can be, as you could see through my demonstration there, quite easy to miss potential paths. So yeah, do take care and practice them lots so you get the hang of it and learn to spot those more easily.